Okay, so this lesson is on inverse functions, and we'll start with our first example. I think we're just going to do number 11. Okay, I'm going to start with a graph. Even though you don't need a graph to answer this question. I'm going to start at 3. 1, 2, 3. Go up 1 over 1, up 1 over 1. And here's the equation of the original function. Its inverse has symmetry about this line, y equals x. So when we're done, we're going to get an answer that's over here somewhere. Okay, so the first thing we do, step 1, you're going to let f of x be y. So y equals x plus 3. Second step, replace x with y. So I'll put a double arrow. So every x becomes a y, every y becomes an x. Third step, we're going to solve for the new y, which is this one right here. So I'm going to subtract 3. Fourth step and the last step, replace y with the inverse notation. So I'm going to graph that one. 1, 2, 3. Put a dot, up 1 over 1, up 1 over 1. And this is the graph in green of the inverse. You can see it does have symmetry about this line y equals x. So that's the main set of tonight's homework. I'll pick another random one to do, but the procedure is always the same. You let y be x, switch every x and y, solve for the new y, and replace it with this notation. Let's do a hard one. Number 18. Actually, I'll do an odd one for the homework. Okay, step 1, y equals x plus 2 cubed. Replace every x with y. So I have to get this guy by itself, so I'm going to raise everything to the 1/3 power. Subtract the 2. And last step, replace y with the inverse. If you look at the instructions, it's asking for 2 things. Find the inverse, verify it. We're not going to verify. This is the verification process where if you do the composite of f and its inverse, it has to give you x. We're just not going to do that, the verification. Let's try something else here. In this section, the directions say, which graphs represent functions that have inverse or inverses? So it's a very simple test. They already said the word function, so it must have passed the vertical line test. So that's the function part. The inverse part, it has to also pass the horizontal line test. So you can see here, if I move this red line, it never touches the graph more than once. So the horizontal line test will tell us if something has an inverse. Inverse can be interchanged with a one-to-one function. a one-to-one function passes both the vertical and horizontal line tests, so it has an inverse and vice versa. Okay, the last part is pretty much the same. I'll do 41 though, because that one's a little bit interesting. So the first thing you should realize is any parabola does not have an inverse, but they fixed it. So a parabola that's been moved down 4, 1, 2, 3, 4, looks like this. And sure enough, it fails to be a one-to-one function. It does not have an inverse because it fails the horizontal line test, but they fixed it. They're saying x is greater than or equal to 0, so that's going to allow me to erase this part of it. And this guy does have an inverse because it passes the horizontal line test. So now to find it, switch x and y, or sorry, replace f of x with y, switch x and y, and we end up with this situation, y equals plus or minus square root of x, but we have to pick one. And how do we pick one? So this little tool is very helpful. So every function has a domain and range. Every inverse has a domain and range. Currently, I'm trying to figure out the plus or minus, which is going to change the y value. So I'm currently looking for this one, the range. If it's positive, I would keep the plus sign. If it's negative, I keep the minus sign, but I have to figure it out. So every domain becomes a range, and every range becomes a domain because this is x information and this is y, and you can see the arrows that switch the locations of those two. So the way around this is I can actually find the domain of f. So the domain of f is given right here. And you can see here it's also greater than 0. So I'll copy that here. Therefore, the range would have to be y is greater than or equal to 0. So that's going to help me choose this information right here. A positive radical x plus 4. And then that's the final answer for this one. They want you to graph the inverse as well. So this is going to be our square root function. I'll do this guy. I'll do him in red. It's moved 1, 2, 3, 4 to the left. It looks like this. And sure enough, it has symmetry about this line y equals x. This line was just to prove it's a one-to-one function. And that's it.